In this video, we will learn about sectors of circles and their areas. First, what is a sector? Let's look at the circle to get a better idea. O marks the center of the circle, OP and OQ are the radii, while PQ is an arc. This part of the circle formed by the radii and the arc is a sector. The sector subtends this angle at O. This part of the circle is also a sector. As you can see, the pink sector is smaller than the blue sector. We call the pink sector the minor sector POQ, and the bigger blue sector the major sector POQ. Note that the area of the minor sector and that of the major sector add up to the area of the circle. The angles subtended at O add up to 360 degrees. Also, note that the larger the subtended angle, the larger the area of the sector. Now that we know what sectors are, how can we find the areas? Let's look at these three examples. In the first example, the sector is actually half of the circle. The subtended angle of the sector is 180 degrees. The ratio of 180 degrees to 360 degrees is half. The area of this sector is half of the area of the circle. Now let's look at the second example. In the second example, the sector is a quarter of the circle. The angle of the sector subtended at O is 90 degrees. The ratio of 90 degrees to 360 degrees is 1/4. The area of this sector is 1/4 of the area of the circle. Let's look at the third example. In the third example, the sector is 3/4 of the circle. The angle of the sector subtended at O is 270 degrees. The ratio of 270 degrees to 360 degrees is 3/4. The area of the sector is 3/4 of the area of the circle. Can you see a relationship between the area of the sector and its subtended angle? The area of a sector is a fraction of the area of the circle. And this fraction is the same as the ratio of the subtended angle to 360 degrees. Hence, if the area of the circle is 20 square centimeters, the area of this sector is half of 20, or 10 square centimeters. The area of this sector is 1/4 of 20, or 5 square centimeters. And the area of this third sector is 3/4 of 20, or 15 square centimeters. In general, to find the area of a sector of a circle, we need to remember that its area is a fraction of the area of a circle, and this fraction is the same as the ratio of its angle subtended at the center of the circle to 360 degrees. Hence, if the angle is theta, and we know the radius r of a circle, the area of the sector is equal to theta divided by 360 degrees multiplied by pi and radius squared. Now let's find the area of this minor sector MON. Suppose the subtended angle is 150 degrees and the area of the circle is 48 square centimeters. The ratio of 150 degrees to 360 degrees is 5/12. Hence, the area of MON is 5/12 of the area of the circle. Since the area of the circle is 48 square centimeters, the area of MON is 5/12 of 48 square centimeters, which is equal to 20 square centimeters. Let's now try this last example. Suppose we want to find the area of the major sector COD. The angles subtended by the major sector COD at the center of the circle is 280 degrees, and the radius of the circle is 9 centimeters. The ratio of 280 degrees to 360 degrees is 7/9. Hence, the area of COD is 7/9 of the area of the circle. However, we do not know the area of the circle. Remember that the area of a circle is pi multiplied by the square of its radius. Since we know the radius of the circle is 9 centimeters, and taking pi to be 22 over 7, the area of the circle is 22 over 7 multiplied by 9 squared. In this way, we can find the area of sector COD, which is equal to 198 square centimeters.